Let's find dw over dt if w is x squared plus y squared and x is equal to 1 plus t squared, and then y is t minus 1 cubed. So there's two ways to do this. You can substitute x and y in terms of t. So instead of x squared, you have 1 plus t squared squared, and then y squared would be t minus 1 cubed squared. So we're just making a substitution. And so this would be 1 plus t to the fourth plus t minus 1 to the sixth. And then take the derivative both sides. You use chain rule. And then you get your final answer. Now the other way to do this is a little bit more complicated. For that, we're going to use a tree diagram. Start off with w. W depends on both x and y, and then x and y depend on t. So when I'm taking the derivative of w with respect to t, there's two ways to do that. I can go along the path of x and then get to t, or I can go through y and then t. So to write that down, we have dw over dt is dw over dx times dx over dt plus dw over dy times dy over dt. So now we go up here. W, the derivative with respect to x, is just 2x. And then dx dt, we go over here. That is 2 times 1 plus t. And then dw with respect to dy is 2y. And then dy dt is 3 times t minus 1 squared. Now we can replace x and y. So x is 1 plus t squared. Y is t minus 1 cubed. But first we'll multiply 2 times 2 is 4. And then x we said is t plus 1. This will be t plus 1 squared, times t plus 1 is t plus 1 cubed. And then we have 2 times 3 is 6. Y is t minus 1 cubed. So t minus 1 cubed times t1 squared is t minus 1 to the fifth. And so either way, we end up with the same answer.